Okay, so now we're going to do just a quick workout of a whole bunch of derivatives, kind of making sure we got all the rules and all the different options that you might encounter. So if your function is polynomial, just use the power rule and the constant rule. Keep the 4, bring down the 5, take x to the 4, take away 1 from the exponent. Keep the -7, and -7x's derivative will be -7. So the final result here will be 20x to the 4 minus 7. Sine's derivative is cosine, so you keep the 3 and then take the derivative of sine, who is cosine. This one needs to be rewritten. The function f, who's 5 over x to the 9, the x to the 9 gets brought up as x to the -9, so that when we take the derivative, we keep the 5, we bring down the -9, and we take x to the -10. We got to take away 1 from -9. So the final result of that would be -45 x to the -10. Radical symbols also need to be changed up. And so a square root is x to the 1/2 power. And so we keep the 3. That's capital F. And then we have 1/2 x to the -1/2. So it simplifies to be 3 over 2 x to the -1/2. I'm not sure if they want negative exponents in the answers. We're just going to leave it like that. This is an exponential function. And in exponential functions, the derivative is exactly the same thing as the function, but you multiply by the natural log of the base. Okay, great. What is the derivative of the natural log of x? It is 1 over x. Now for 8 over x, we're going to rewrite that function as 8x to the -1 so that we can keep the 8, bring down the -1, and take x to the -2. Remember, we have to take away 1 from it. And so that is -8x to the -2. Okay, now for e to the 3x, the derivative is e to the 3x. Whenever you have your function as e to another function, your derivative is exactly that same thing. You don't need to multiply by a natural log of e because that's a 1, and then you multiply by g prime of x for the chain rule. So 3x's derivative is 3. So you can pull that constant out front and have e to the 3x times 3. Cosine's derivative is negative sine x. So you have the 2, and then you have negative sine x. So I just call it -2 sine x. Okay, x to the -5's derivative is just going to be -5 x to the -6. Be careful there. You're at -5 and you have to take away 1. Okay. All right, now we have a product rule. We have a first function and a second function, and we have to execute the product rule. The derivative of the first function is going to be 3x squared. That gets multiplied by the second function, who is e to the 2x. Then you put a plus sign, and you leave the first function alone, x cubed. That gets multiplied by the derivative of the second function, e to the 2x. But don't forget to multiply by 2, the derivative of the exponent. You can just leave it like that. Maybe pull the 2 out front, in front of the second term there. Sine of x squared. This would be a chain rule. It's a function inside of a function. So you take the outside function, sine's derivative is cosine. You take the derivative of it, but you leave the inside alone. Cosine of x squared, and then the chain rule, multiply by the derivative of the inside. So we get the cosine of x squared, and we times that by 2x, the derivative of the inside. So if you ever have the sine of some g of x as your function, your derivative is cosine of that same g of x times g prime of x. If you ever have the natural log of some function, g of x, don't worry about the fact that this is g here, but I'm just talking in general here. Your derivative is 1 over g of x. because that's how log works, but then derivative of the inside chain rule would be g prime of x. So over here we do 1 over x cubed plus 1 times x cubed plus 1's derivative, 3x squared. And you can put them on top, 3x squared on top of x cubed plus 1 if you want. Okay, and then we have the square root of x as your first function, cosine x as your second function. After you do enough of these, you'll get the hang of how to find a shortcut. Yes, it's x to the half. Yes, you bring down the 1/2 and take x to the negative 1/2, but you can simplify that as having 1 over 2 root x. So when you see f as root x, I want you just to know the derivative is 1 over 2 root x. So the derivative of the first is going to be 1 over 2 root x times the second, cosine x, plus the first, root x, times the derivative of the second, who is negative sine of x. Okay, great. And what we did was the product rule. The derivative of the first times the second plus the first times the derivative of the second. Okay, now next up we have 7 to the x on top of x cubed. And there's a couple things we can do there. We can bring it up and make it a product rule, or we can do it as a quotient rule. Let's do it as a quotient rule. You take the denominator and square it. So if that's your function, your derivative is the denominator squared. Then you bring the denominator up to the numerator, and you multiply by the derivative of the numerator. It's an exponential, so you repeat it and you multiply by the natural log of the base. Then you put a minus sign and you leave the numerator alone and take the derivative of the denominator, power rule, 3x squared. So essentially that's it. That's going to be your derivative. I could put that in the box there. And then one more here. We bring down this 9. We take x cubed plus 7x to the 8, and we times by the derivative of the inside, who is 3x squared plus 7. Okay, that's the power in the chain rule. Okay. I don't know where all the writing went, but that's it. All right, great. And these last two I'll do on one last video.